Well, hello everybody, and welcome to Chapter 1, The Basics of Statistics. We're going to cover some of what your book covers, but also a little extra because I'm not sure how long it has been since some of you have taken statistics. You might have forgotten a few of the key terms, and so we're just going to go over kind of a summary of some of the important terms that we'll be using through the semester. So as I said, this is mostly a review of what you've learned in your previous statistics class, but it is not surprising to me if you don't remember some of this information and need a refresher. Some of you may have taken stats last semester. Some of you may have taken statistics 5 years ago. And truly, even if you just took it last semester, it's not surprising to not remember some of these terms. If what we discussed today is not thorough enough, please refer to your old statistics textbook, or I can refer a textbook I like. Nolan is the author of the textbook, or of course go to your TA's office hours and they will help you as well, or my office hours. All right, so some important terms. We talk about a population and a sample quite a bit in statistics. So a population is the entire group of individuals. So if I'm interested in looking at the relationship between class standing of students at SDSU, so whether they're freshmen, sophomore, juniors, or seniors, and their academic performance, meaning their GPA. So is there a relationship between class standing and GPA? Of students at SDSU, what is the population? Well, the population would be every student at San Diego State, every single student, ones who only take one class, ones who only take, or are graduate students, who are engineering students, who are psychology students, every student at San Diego State, that is the population. Now, usually populations are so large that a researcher can't examine the entire group. So even trying to, get information from every student at San Diego State would be pretty tricky. But what if my question of interest has to do with, does a particular medication help with individuals who are depressed, diagnosed with depression? Well, who would my population be? Everybody in the whole country, we could even say in the whole world, who is diagnosed with depression. Well, that would be impossible for me to try to study the entire population. It's too large. It would take me forever. It would cost too much money. It's just impractical. So instead of studying the entire group, we often select a small group, a sample, that is selected to represent the population. And the goal is to use the results of the sample to help answer questions about the population. So our research questions are usually about the population, but we use a sample, a small group, to help us answer those questions. So in terms of my study on San Diego State students, I might go and try to find 200 San Diego State students and ask them all what their GPA is and what their class standing is, and from that data, try to say something about the population. Same with a study on a new medication for depression. I might try to find a sample, a small group of 100, 200, 300 people who are diagnosed with depression, give them all this new medication, see if it works for them, and then use that information to say something about the greater population. Just remember, our main research question is about the population. It's not about the specific people in our sample. All right, we're going to go through two different branches of statistics through this class. We start with descriptive statistics. Descriptive statistics describe your data. They organize, summarize, and communicate what your data looks like. What kind of descriptive statistics do we use? Often tables and graphs. You might remember the word a frequency table or a frequency distribution or a histogram. We'll be working on those. And then other numbers that we may calculate to describe our data would be measures of central tendency, things like mean, median, mode, and variability, like standard deviation and variance. The last or second part of the class, we'll be talking about inferential statistics, and these are the statistics we do where we use sample data to make an estimate or an inference, again, inferential statistics, make an inference about the larger population. And since the sample is really only part of the whole population, sample data provides us limited information about the population, and then we need to kind of extrapolate or make an inference about it. All right, variables. Variables, oh, and I should just go back. These inferential statistics, these are things you probably remember: t-test, a z-test, ANOVA, correlation. Maybe you remember those terms. You don't necessarily have to remember how to do them, but those are the inferential statistics I'm talking about. All right, variables. So any information that we study is basically a variable, and it could be income level or aggression level or test scores or voter preference. All of those can be variables. The only key is that a variable must be able to take on at least two different values. So are you right-handed or left-handed? Are you a student or not a student? And if it can't take on at least two different values, then it's a constant. And we wouldn't be studying it. We have to study variables. These variables can, like I said, range from two values to many different values, like what is your score on a test from 0 to 100, or what is the temperature from, I don't know, negative, however cold it could be, to 110 degrees, right? There could be a huge range of variables, but there has to be at least two values. And variables really represent variability, which is differences, right? That's what variability means, differences. And variability is the key concept to all of our statistics. We are always trying to explain variability. We're going to talk about why are people different. That's why we do our research studies. Why do some people have higher GPAs than other people? Why do some people have higher levels of depression than other people? Why do some people have higher levels of anxiety than other people? We're really interested in these questions about variability or differences. And as we talk about variables through the class, remember that they represent these differences that we're trying to explain. We want to understand why people, in the case of psychology, are different. And we'll keep coming back to this idea. There are two types of variables. Again, you might remember this from statistics. There's an independent variable or an IV and a dependent variable or a DV. And the independent variable is the variable that we think causes a change in the dependent variable. So the independent variable or the IV, this is the one that we manipulate as a researcher. I choose its value, I choose the variable and I choose its values, and we think of it as the cause in a cause and effect relationship. So if I think that the amount of sleep you get the night before a test will influence your grade on the test. And so I am going to have students come into my sleep laboratory, and I'll have two groups. I'll have one group that I make them stay awake all night. They get 0 hours of sleep. The other group gets 8 hours of sleep. And then both groups take the same test in the morning. Let's just call it a statistics test. Okay, and I think that the amount of sleep is going to have an effect on their grade on a test. So the independent variable, that's what I think is going to cause a change in the dependent variable. It's the one that I'm manipulating, and in this case, it would be sleep or hours of sleep. And I'm choosing, we call it values or its levels. In this case, I'm choosing two levels. I'm choosing the independent variable is amount of sleep the night before a test. the levels are one group is getting 0 hours of sleep and the other group is getting 8 hours of sleep. Now I could have chosen one group will get 4 hours of sleep and one group will get 10 hours of sleep. Or I could choose 4 different groups. One group gets 0 hours of sleep. One group gets 2 hours of sleep. One group gets 4 hours of sleep. One group gets 6 hours of sleep. I'm deciding this. That's the independent variable. The dependent variable, or the DV, this is the observed variable or the measured variable. We measure it as a response or as an effect of the independent variable. So again, in a cause and effect relationship, the dependent variable is the effect. So in this case of sleep and test scores, my dependent variable is test scores, right? Because I'm measuring that. And I think that test scores are dependent on sleep, right? That's kind of how that works. And I'm not manipulating it. If I manipulated test scores, well, that would be very unethical. All I'm doing is measuring. How are people doing on this test? So for example, does the color of paper a test is printed on, white paper versus blue paper, influence students' test scores? So you could actually pause this for a second, try to answer this question. What's the independent variable? And why don't you figure out what the levels are, and then the dependent variable, and then restart. So hopefully you did that. So the independent variable would be color of paper. It's what I'm manipulating. So I'm manipulating color of paper. The levels are white versus blue. Now you can see it would be incorrect if I said the independent variable is white versus blue, because that's not really what I'm manipulating. My independent variable is the color of paper, and the levels are white versus blue. And again, I'm choosing this. I'm manipulating it. It could be white paper versus green paper, or white paper versus pink paper, or pink paper versus blue paper. Totally up to me. And the dependent variable, what I'm measuring is students' test scores. So in research, we again have our independent variable. That's the one that you manipulate. It has to have at least 2 levels, but it can have more. The dependent variable is the one that you measure, and it is related to, or we think that there's going to be a change in the dependent variable that is caused by the independent variable. And a confounding variable, this one you don't want. Confounding also means confusing. You do not want a confounding variable. This is a variable that you try to control or randomize away in your research design. And when you take a research methods class, you'll talk about how you do that. But it confuses your other measures. For example, if I did this study of white and blue paper on test scores, and I found that everyone who, the group that took the test on the white paper did better than the students who took the test on blue paper. But what if I found out that everyone who took the test on white paper was a senior in college, and everybody who took the test on blue paper were freshmen? Well, do you see that class standing now would be a confounding variable? Because do I know that people do better if they take the test on white paper versus blue paper? Or is it possible that because the people who took the test on white paper were older, they've been in college longer, they've learned more, so they've done better because they were seniors, compared to the freshmen who took the test on blue paper? They haven't been in college as long, they haven't learned as much. So now we have a confound. You obviously would not want to set up your experiment in this way. And again, this is a research methods question that you would learn more about, but important to just be aware of it. Your book does talk a lot about group versus score variables, and this is quite important. This is how we will talk about types of variables in this class, mainly because it simplifies our ability to kind of decide what statistical test we're going to use. But you can, kind of the simplest way to break down your type of variable is that either it is a group variable or a score variable. And a group variable is a variable that assigns people to groups. So any kind of named groups, let's see, I want to, again, it could be class standing. Are you a freshman, a sophomore, a junior, a senior? What is your major? Are you a psychology major, a biology major, etc.? What is your relationship status? Are you single? Are you dating? Are you divorced? Are you married? Religion, right? What is your religion? What is your, I don't know, color of your eyes, right? Those are all groups, named groups, and you would fit into one of those groups or categories. Those are what we call group variables. Score variables, on the other hand, are variables that represent how much or how many of something we have. And so these are basically number variables, anything that you would represent with a number. So your score on a test, your GPA, how old you are, how much you weigh, how many hours of sleep you get a night, how many friends you have, anything that's answered with a number is a score variable. So group versus score variables. This is important, and you'll be working on that in your homework as well. Then in terms of these other levels of classification, this is probably what you learned in your previous statistics classes, the idea of nominal, ordinal, interval, or ratio. We are going to go through this because it's important statistically and intro stats classes. This is the way we typically describe the four types of variables, but your book, and pretty much after today, will use this group versus score categorization. So this is a summary of what I'm going to talk about here. So we'll start with nominal variables, or basically group variables. And this is the same as that group variable idea, where people are assigned to different groups, and those groups have names. There are no numbers associated with those groups. So we talked about eye color, marital status, religion, any category. And again, you might measure that category in a number of ways. This is all a research methods question, right? Gender could be two choices of male or female, or male, female, other. There's probably a number of different categories we could decide to use on our, let's say, questionnaire or survey. But if you're asking people to assign themselves or place themselves into a single group, that is a nominal or group variable. Now, ordinal, this is the idea of rank order. Ordinal, rank order, first, second, third place. And that's really the best way to think about it. That there are numbers, because first, second, third, those are numbers to some extent, but they're not like actual numbers that you can do math with. You can't add up first place plus second place doesn't give you third place, if that makes sense. And what we say with ordinal variables is the size of the interval between these numbers is not equal. And this should make sense to you if you've seen a race. Let's imagine a race where people are running a mile. Well, it could be that the first place winner is just an absolutely outstanding runner and has a very quick time. And then it's quite a bit more time before the second place person comes. And then maybe third place person comes right after, or gets to the finish line right after second place. And so first place is first, and then there's a long interval before we get the second place person, and then the third place person comes right after that, right? That's possible. Or it could be like a photo finish between first and second place, and then a real long time before the third place person finishes the race. All you know with ordinal rankings is that the first place person came in first, and the second place person came in second, and the third place person came in third, but you don't know anything about the distance between these numbers. So that's the idea that the size of the interval between the numbers is not equal, and so we can't really do math with these numbers. We're really limited to the type of statistics we can do. Now, interval and ratio, and I will say we're really not going to talk much about ordinal, if at all, in this class, because the statistics we use would be a different type of statistics than we're going to cover. It would be in a more upper division or a higher level statistics class. Now, interval and ratio, these are both score variables, as you can see here. In our textbook, we're going to consider them both the same as score variables, but I will tell you the difference, and you probably, or you might remember these differences from your statistics class. So interval and ratio are very similar, but this is when the numbers that you get from your data, and I'll tell you what's exactly the same about them, and then I'll tell you the slight difference that would differentiate between interval and ratio, that you get number data in both cases, and you assume equal distance between the numbers on the scale, or equal intervals. So these are numbers, right? 1, 2, 3, 4, and you assume that there's equal distance between the numbers on the scale. The typical example for interval is temperature. And so you can see here, if you have a thermometer, right, between 60 and 61 degrees is 1 degree. Between 61 and 62 is another degree. Between 62 and 63 is another degree. These are all equally spaced. And between 80 and 81 and 81 and 82, again, it's still 1 degree. It doesn't matter where you are on the scale. Every time you go up 1, you're going up the same amount, in this case of temperature. These are spaced apart. The difference between interval and ratio scales of measurement, which we're going to get to next, is that in an interval scale of measurement, we say there is no true zero. What does that mean? What is a true zero? Well, a true zero, think back to elementary school, and you're learning numbers. What does zero mean? Right? Zero means nothing. Zero is the absence of something. And so temperature is an example of that, in that if you are at the temperature of 0 degrees, now I don't know that I've ever been somewhere where it's 0 degrees. I can't say I'm unhappy about that, but maybe some of you have. When it's 0 degrees, what is the temperature? Well, it's very cold, right? 0 doesn't mean the absence of temperature, that when it's 0 degrees, there is no temperature, correct? And so we say for an interval scale, there is no true zero. Whereas with a ratio scale, again, you get number data and the distance between the numbers on the scale, whatever scale you're using, should be equal. But there is a true 0 point. 0 means 0. So if I ask you, and we do this in neuropsych testing, to tap your finger on the table. We do finger tapping. Your pointer finger, you lay your hand flat on the table and tap your pointer finger as many times as you can with your right hand, and then as many times as you can with your left hand. And we count them up, how many times you could tap in, let's say, a minute. So if someone taps 0 times, right, that means 0. It's the absence of finger tapping. There was no finger tapping. And we use ratio scales for a lot of more kind of physical measurements where 0 actually means 0, or money, right? If you made $0 last year, well, that's the absence of money. You have made nothing. We use them pretty much the same in statistics, a ratio or interval scale. We do pretty much the same statistics either whether our data is on an interval or ratio scale. Typically, we think of our or our psychological or neuropsychological tests on an interval scale. For instance, things like an IQ test or a depression questionnaire. If someone got a 0 on an IQ test, we wouldn't necessarily consider that the absence of intelligence. We would consider it a very low score, another point on the scale, just like 0 is a very low temperature. But we wouldn't necessarily consider an IQ of 0 the absence of intelligence. It's just kind of lower than our test is able to measure. Same with depression. If someone got a 0 on a depression questionnaire, would we say they have absolutely no depression? Well, somewhere in there they might have a little bit of sadness, a little bit of depression. It's just lower than we can perhaps measure. And so we would, again, consider that an interval kind of measurement. Most of our psychological tests, that's what we consider them. And depending on what you're measuring, you could measure that variable in a number of different ways, right? If we were doing a cookie study, and who would not want to do a cookie study, in a nominal way, I could ask you, what's your favorite cookie? And you're going to tell me Oreo, chocolate chip, oatmeal raisin, the little pink and white circus cookies, I don't know. You're going to tell me a name. And that's a nominal way to measure cookies. I could do it in an ordinal way and say, rank your favorite cookies. Here's 5 different cookies, and I want you to rank them, right? Oreo, chocolate chip, oatmeal raisin. Let's just go with 3. Okay. And so you put them in order. Well, my first place favorite cookie is Oreo, second is chocolate chip, and third is oatmeal raisin. But all I know is that from that data, this person likes Oreo better than chocolate chip and likes chocolate chip better than oatmeal raisin, but we don't know how much difference. Is it like Oreo is the best and nothing else compares? Everything else is far away, or is Oreo and chocolate chip a close tie and oatmeal raisin is way at the end? We don't know that. Interval, of course, I could ask, what's your favorite temperature to eat cookies at? Ratio, I could put you in a room with a whole bunch of cookies and say, eat as many as you can, and then I'll count how many are left. And if 0 cookies are left, right, that's the absence of cookies. Reliability and validity, important terms as well. Reliability means consistency. If you have a reliable measure, that measure is consistent. If you have a reliable IQ test, it gives you a consistent test over and over again. You could think about this like a bathroom scale. If you weigh yourself today and then get off the scale and weigh yourself, let's just say in 5 minutes, you should pretty much get the same weight. If you don't, if you get on the scale right now and you weigh 130 pounds and then you get off the scale and you get back on 5 minutes later and nothing has changed, and then it says 200 pounds, and then you get off the scale and you get right back on it and now it says 17 pounds. Well, that is not a reliable or a consistent measure, and that's not very useful at all. Same with our psychological tests. If I give you an IQ test today, your score should be very similar as if I give it to you next week, as long as nothing has happened. You haven't had a head injury or something between the 2 tests. Now, a valid measure means that your measure or the questionnaire, the tool that you're using to get your data from, measures what it was intended to measure, meaning that If you're trying to measure the weight of something, well, a scale is a pretty good way to do that. If I were to say, well, I want to ask you a question. My question is, what's your favorite color? So think about it. What's your favorite color? And then if you answered blue, you are going to be diagnosed with depression. This is my new depression questionnaire, and I just need to know your favorite color. And blue, we all know, is a sad color. And so if you picked blue, then I'm going to diagnose you with depression. Now, of course, this is not valid, right? There is no relationship between your favorite color and whether or not you're depressed. So even if your favorite color is blue, which mine is, you do not need to worry. But that could be somebody's depression questionnaire, depression test, but it's not valid. It is not accurately measuring depression by asking what your favorite color is, right? You would need to ask things about, do you feel sad? Do you feel hopeless? Do you feel worthless? Questions like that would make it a more valid measure. And so a good variable is one that is both reliable, meaning it's consistent, and valid, meaning it's measuring what you want it to measure. So if you had a scale that read 5 pounds, each time you placed a 10-pound bag of potatoes on it, is this scale reliable and is it valid? Why or why not? Maybe think about it for a second. You could pause here if you want. So the question, is it reliable? Meaning, is it consistent? Well, it is consistent because every time I place this 10-pound bag on it, it tells me it's 5 pounds. So yes, this is a reliable measure. It's a consistent measure. But is this scale valid? Is it measuring what I want it to? Well, clearly not. It's not valid because I know this bag of potatoes is 10 pounds, and every time I measure it, it's telling me it's 5 pounds. It is not measuring weight in a valid or accurate way. So you can see why both parts are very important, reliability and validity, and you might have reliability without validity, or validity without reliability. You have to kind of look at each part as you're designing a research study. Again, this you'll spend a lot more time on in research methods. Just a bit about scientific writing. You have chosen to be a psychology major at a university. You're training to be like a professional. And so you have to start writing as a professional. And the kind of writing that we do in psychology is very different than maybe books you would see at your local bookstore, or kind of self-help psychology books. We use the American Psychological Association style, APA style, and we're going to learn how to write our statistics in APA style. There is a manual. It's a reference book that shows you all the details. And again, as you move on into other classes where you're required to write research papers and into research methods, you'll go through all the details. We're really focusing on how you write your statistical results in proper APA format. And this style has been adopted by many other sciences and journals and disciplines. And so even if you decide, oh, I'm not going to be in psychology, I'm going to, get a master's degree in sociology or counseling or anthropology or biology, very many disciplines use the same style. So we write in a very standard format, and that helps us as readers easily identify the information we're looking for. And the goal of scientific writing is to be very clear. And so if we write in a very standard structured form, we can, it's easier for people to understand and find what they're looking for. So the research findings themselves should be interesting rather than the writing style. You'll see it's a pretty boring writing style, and while it's a lot to learn maybe in the beginning of this class, by the time we get to the end of the class, you'll be like, oh, we're writing it this same sentence again in the exact same format. That's the goal, boring and clear. This is not the time for really fancy, exciting types of writing. That's for your like creative writing classes. And so we have to practice this a lot, and we'll be practicing writing these little result sections pretty much from the start of the class till the end of the class. And so that is really the best way to learn. Practice, practice, practice. And like I said, we're focusing on the appropriate writing of a statistical results section. And we're going to be pretty picky on when you turn in your homework and your writing, because this is science, this is statistics. It's kind of the whole point of science and statistics is to be very, very accurate. And so we are going to be marking off as incorrect little tiny typos because we expect that you're going to do the work, check it over, look for typos, right? If scientists publish papers with typos all over them, well, then science is no good, right? We couldn't trust it. That's what we're preparing you here to do. So you really do need to be very careful with what you turn in. In terms of things we're looking for, being correct, so no typos, right? Be sure that you've capitalized things that should be capitalized and all of that. Grammar, we really don't have much grammar, so don't worry about that. Factual, meaning correct. If you run a statistical analysis and it says the mean age is 17 years, you find that from your statistics, and then you write as a typo, the mean age is 177 years, well, that's a problem, right? You're going to get marked off for that. So be sure you're looking at all the details. Be clear. We're going to ask you to be understandable, and I'm going to give you kind of a format that all you do is follow it and plug in the numbers that you get. So I'm not expecting you to create a statistics section, particularly not in the beginning, just following it, and if you do, it'll be understandable. We really aren't going to have any acronyms or anything like that. Be concise. You're going to omit needless words, and again, I will give you the sentence you need. You don't need to add anything to it as we move on through our homeworks. And just be predictable in that following APA format exactly. We are going to expect that when we give you a template sentence, you'll look at the analysis and fill in the template pretty much exactly as we've given it to you. Once you do that, then you'll have learned how to write an APA style. As you move on to higher level classes, to graduate school, of course you will start changing these sentences a little bit and making them more your own. But right now we're just going for being sure that you're getting all the important parts in exactly the way that is expected in APA writing. And I will teach you how to, again, we want our writing to be easy on the eyes. We want our writing to be easy for people to read. And even though it's a small difference between these two sections, you'll see. Results revealed that the sociologists with a mean of 4.34 and a standard deviation of 1.51 were lower than the psychologists with a mean of 5.29, standard deviation of 1.57. I could just stop right there, and I would ask you, if we were together in person in class, what is wrong? Just stopping right there. And maybe you can see that it's confusing. If you don't know what this sentence is about, you've revealed that sociologists, and here's their mean of what? I don't even know what we're talking about. And they're lower than the psychologists, and here's their mean. Still don't know what we're talking about in terms of self-esteem. Finally, 3 lines down, I know what the sentence is about. And so just think simple things like the sociologists had lower levels of self-esteem with a mean of 4.34 than did psychologists, and this difference was statistically significant. Again, I'm going to teach you how to write like this, and it's these small little things that are important to writing a good paper. Plagiarism, extremely important. I take this so seriously, and I hope you all listen very closely to this. Never use anyone else's words, and that's another student, an internet source, another research paper. Don't cut and paste and think you'll paraphrase later. This entire class must be done on your own. And it's actually pretty simple for us. And every semester we find people who have tried to copy each other's papers, and you will get a 0. You can look at the academic honesty policy in the syllabus. But it's really important because plagiarism is very important in scientific writing. You aren't allowed to plagiarize other sources. And so we are really trying to train you from now how important this is. And again, if you have questions about plagiarism, feel free to ask me. Feel free to ask your TAs. We're here to help. All right? All right, everybody. Well, that was the beginning, and thank you very much.